Hello everyone, my name is Zahra Hashim, and in this video I'll be sharing my approach for modeling Mumbai's International Airport parametrically using Grasshopper for Rhino. The building is located in Mumbai, India, and designed by SOM architects. The building is designed in an X-shaped plan, and on top of that plan you can see a triangular roof that is supported with 30 mega columns, and on top of each column there is a domed skylight. From the plans you can see that the columns and skylights are coming from the diagrid pattern on the roof. The pattern on the column and ceiling is inspired by the peacock feather, and it is basically a diagrid where each cell is offsetted and two opposite corners are smoothed out, and within the center of each cell there is a circular lens that is pushed upward to pass light into the building. So here's my attempt. In this exploded axiometric, you can see how the building parts are coming together. I'll be summarizing my approach on 3 parts. The first is creating a module column and its pattern. The second is the roof, and you can see that the roof consists of 2 parts, the upper part with the skylights and the lower part which I oriented the columns on. These are some of the attempts for creating the column. Each was created differently. The first attempt was created using meshes, Mesh Plus and Weaverbird plugins. The outcome became smooth to a point that the cells became an oval and we no longer see the edges. The second attempt was created using NURBS, and this is based on a polygon. Lastly, for this attempt, I've created part of the column and then used array polar to complete the shape, which is the longest yet best way out of them. For my first trial, I started with a polygon and then moved it in the Z direction and scaled it up gradually to create the form of the column. And I'm using this graph mapper to control the shape of it. And then for creating the pattern, I'm using lunchbox diamond panels. And then I'm turning them into meshes. I'm using Weaverbird Stellate to create the depth. And then I'm taking the upper part and I'm culling the openings. And then I'm using the kangaroo solver to reshape the openings to fit circles. Moving on to my second trial, I use the same definition for creating the form of the column, and then I'm using the diamond panels. I'm taking the upper part and I'm doing an offset, and then I'm smoothing out the 2 corners using fillet, and then I'm taking the centroid of each cell to create the circles, move them in the Z direction, and lofting everything together. For the lower part, I'm offsetting and I'm drawing an arc in the middle of each cell to create those bumps that can be bubbled out like this, or they can go deeper inside, just like that. And since this trial is based on a polygon, we can go and change the number of segments. We can go from 4 to 5 to 6, so on and so forth. Moving on to my last trial, I started with a line, and then I drew the section curves, lofted them, and then I extruded the lower part, and then I'm using the array to complete the shape. And then I'm using the same definition for creating the pattern. But in this trial, I got 8 segments culled out instead of 4. So to include the ones in the middle, I've separated them from the corners, and then I applied the pattern on them. And now I got the column complete. And you can notice that the pattern is happening gradually from the bottom to top, and this is controlled by an attractor point that is now set at the bottom. This animation captures one of the parametric changes that can be made, which is moving the attractor point from the bottom to the top of the column. To create the roof, I started with a polygon, and then I smoothed out the edges. And since this is a trimmed surface, when I used the diamond panels, it didn't work. So I used the panels within the boundary that I've just created. And then here I'm anchoring the edges of the mesh to the boundary curve using the kangaroo solver to fit the mesh within the boundary. And then I took the edge and moved it in the Z direction twice and scaled it different times to get this edge that will connect the 2 surfaces. And now we get the roof. And since the roof is based on a polygon, we can always go and change the number of segments. After that, I use this definition to cull 4 rows from the pattern. That then I will use them to create the skylights. So I took the edges and smoothed out the 2 corners, and then extruded them a little bit, and then I'm fitting a circle within each of them. and then plugging that into the kangaroo solver to create the base surface for the skylights. And then I triangulated the mesh and used Weaverbird window and frame to create the glass and mullions. To create the pattern on the ceiling, I started by creating the pattern on one single diamond and then morphing that all over the ceiling. After that, to create this pattern on the ceiling, I've selected all the triangles that left from the diamond panels and then merged them, and then I culled out the triangles and kept the diamonds only, and then I've created the patterns on them. After that, I took the column that I did previously and morphed it on each cell on the roof. And now after we morphed the columns and applied the pattern on the roof, this is what we got. So you can see that where the column meets the ceiling, there's this sharp edge where it doesn't have a pattern. So I've repeated the same process that I did to create this pattern on the roof, which is selecting the triangles that left from the diamond panels, merge them, and then create the pattern on them. And now we got that edge blended, and the pattern now flows from the ceiling to the column nicely. And here are the final results.